Okay. So applications of quadratic equations. So the first one says the product of two consecutive integers is 14 more than 6 times the smallest integer. So what we're going to have to do here is first we're setting up the problem, then we're going to solve the problem. So we don't know what these two integers are, so they're going to become variables. What does consecutive mean?
Back to back.
Yeah, back to back. So this tells us that we can have one integer and let that be represented as x. So let x equal the first integer. Since it's consecutive, that next integer has to come after it. So we're going to let that be x plus 1. Okay, so we're still using the same variable x. X is representing the first integer, and x plus 1 is representing the integer that comes right after. Okay? So forming our equation now, it says the product of two consecutive integers. So product means what? What operation is the word product? Multiplication. So we are going to take the x and the x plus 1 and multiply them. So x and x plus 1. Okay, that's the first part. Then it says that's how I knew there was an equal sign, 14 more than. So 14 more than would look like what? 14 plus, but that more than tells us that's going to be at the end, that plus 14. Then it says 6 times the smaller integer. So in this case, the smaller integer is that x or x plus 1? X. So we're going to have 6x. Okay, so we have our smaller integer x times our larger integer x plus 1 is equal to 6 times our smaller integer plus 14. Now that we have everything written out, we're going to simplify. And what's going to be the first thing we're going to simplify?
The left side.
Good, that left side, so we can distribute the x. So I'm left with x squared plus x is equal to 6x plus 14. Since we're dealing with quadratic equations, remember the standard form for that was that ax squared plus bx plus c equals 0. So we need to get our equation looking like the standard form. Okay? So what do we have to do to that 6x and that 14? Move to the other side. So I'm going to subtract 6x, subtract 14 over to the other side. And I'm going to get x squared, and then x minus 6x is what? Negative 5x, and then bring down that minus 14 equals 0. So now I have a quadratic equation in standard form. So now I need to factor this. So we're going to go ahead and just use the AC method by multiplying those two numbers. So what is our number in front of x if we don't see it, that x squared? 1. So we're doing our a times c, which is 1 times negative 14, which is negative 14. And our b value, let me move this real quick. And our b value is that negative 5. So we need two numbers that multiply to negative 14 but add to negative 5. What would be those two numbers? Good, 2 and negative 7. So 2 and negative 7. If we multiply them, we get negative 14, and if we add them, we get negative 5. Okay? So we're going to go ahead and place those numbers into our equation. So we have x squared plus 2x minus 7x minus 14 equals 0. So now we have 4 terms, and that tells us to do what? Factor by grouping. Okay, so group them up, and then I'm taking the GCF out of each part. So what's the GCF of the first one? Good, just x, and I'm left with x plus 2. And what about the second one? -7, because I want my parentheses to match, so I'm left with x plus 2. Okay, so now I have the factors x minus 7 and x plus 2 equals 0. That equals 0 there tells me I can solve. So what am I doing to each of my parentheses? I'm going to set each parenthesis equal to 0. So x minus 7 equals 0. X plus 2 equals 0. I'm going to add 7 over, and I get x equals 7. Subtract 2 over, and I get x is equal to -2. Okay. Are these my answers? Or I should say, are these my entire answer? Because this just gives us x. But what was the other variable that we had? X plus 1. That in the beginning, that x plus 1 up here represented our second integer. So what this gave us is just the first integer. So we're going to have to add 1 to each of them to get the second integer. So we're going to have 4 answers here. So I have 7 plus 1, which is 8. -2 plus 1, which is -1. So that means I have my answers of 7, 8, and -2, -1. All of these are my answers. Meaning for my problem, I could have 2 possible consecutive integers. I could have 7, 8, and that would work for this problem, or -2, -1, and that would also work for this problem. Remember, since these are applications, there might be that additional step at the end to get our actual answer. Okay. Any questions on number 1? Okay. Now let's look at number 2. Number 2 says a rectangular sign has an area of 40 feet squared. If the width is 3 feet shorter than the length, what are the dimensions of the sign? So for these problems, it's easiest to draw a picture. So I'm going to go ahead and draw my picture. It's a rectangular sign that we know that the area, so area of a rectangle is what? Area equals length times width. Okay, and we know the area is 40. Okay. We also know that the width is 3 feet shorter than the length. Okay, so let's just say length is L, because it doesn't tell us anything more about the length. And the width, it tells us, is 3 feet shorter than length. So how would I write that? How would I write 3 feet shorter? -3. So length minus 3, because it says shorter than length. So now I have my width and my length, so I can plug in those into my equation of area equals length times width. So we know length is just represented by that L, but width is represented by L minus 3. So now what we're going to do is we're going to simplify this equation. And by doing that, we're going to do what with the L that's on the outside? Distribute. So I have 40 equals L squared minus 3L. Okay. And I want this in terms of that standard form for quadratic equation. So it has to be equal to 0. So what am I going to do to that 40? Subtract it over. So I have L squared minus 3L minus 40 equals 0. Okay. Now I have a proper quadratic equation. So I'm going to do the A times C method. And in this case, what is my A and what is my C?
1 and negative 40.
Good, because there's not a number in front of that L squared, so we say it's 1 times negative 40 gives us negative 40. And what is our B value? Negative 3. So we need two numbers that multiply to negative 40 but add to negative 3. What would be those numbers? 5 and negative 8. Good. So 5 times negative 8 gives us negative 40. And if we were to add these numbers together, we would get negative 3. So these are the terms we're using. So I have L squared plus 5L minus 8L minus 40 equals 0. 4 terms tells me I'm going to do factor by grouping. So what would be the GCF I can take out of the first parenthesis? Just an L, good. So L, and I'm left with L plus 5. What about the second parenthesis?
Negative 8.
Negative 8, because I want that to match my other parentheses. So if I take out a negative 8, I'm left with L plus 5. So I have L minus 8 and L plus 5 equals 0. Okay. So that tells us I'm going to do what to each parenthesis?
Equal each one to 0.
Equal each one to 0. So I have length minus 8 equals 0. Length plus 5 equals 0. And I'm going to solve for L in each one. So in the first one, I get L is equal to 8. And in the second one, I get L is equal to negative 5. Okay? Since we are talking about a real-world problem that's dealing with the length of an object, which one of these answers do I know right away is not going to work?
Negative 5.
Negative 5. Why?
You can't have negative length.
Good, you can't have negative length. So that means the only possible answer here is when length is equal to 8. So that gives us length, but how do we use that number 8 to find width?
Subtract 3.
Good, subtract 3, because so we know length is 8. Width we know is length minus 3. So we do width equals 8 minus 3, which gives us 5. So this tells us that our length is 8 and our width is 5. And then feet, of course, because we're dealing with feet. Okay. So in this problem, we had to use that the knowledge that we are dealing with a real-world problem where we're measuring an object, and so we could never have a negative length value. Okay, let's look at number 3. Number 3 says a stone is dropped off a 64-foot cliff and falls into the ocean below. The height of the stone above sea level is given by the following equation. H equals negative 16t squared plus 64, where h is the stone's height in feet and t is the time in seconds. Find the time required for the stone to hit the water. Okay, so this is another one where it's helpful to draw our diagram. Okay, so we have a cliff. Okay, we have a rock falling off the cliff. And then we know from the height of the cliff to the sea level is 64 feet. Okay. So there's our diagram. We have our cliff, our rock falling off the cliff, and then we have the height from the top of the cliff until it meets sea level. Okay. So we have the equation here. H is equal to negative 16t squared plus 64. it wants us to find the time where the stone hits the water. So when the stone hits the water, what is the height above sea level? So once our rock gets all the way down to here, what's the height? 0. So we're going to be plugging in 0 in for which variable? H or T? H, because that H is the height. So we have 0 is equal to negative 16t squared plus 64. Okay. Now we have an equation that is in that quadratic form. Okay. The only thing we're missing here is that b value. Okay. We're still going to factor it how we know how to, except we're going to check if we can take out a GCF. So there are a GCF that we can take out of negative 16 and 64. Even larger.
16.
Yep, that negative 16. So we know the GCF is that negative 16. So if I take out a negative 16, I'm left with t squared minus 4. Okay. What does this t squared minus 4 remind you of? What type of factoring?
Perfect square.
Perfect square. So since this looks like a perfect square, we know that the factors of t squared minus 4 is going to be what? Remember, it's going to be 2 parentheses. Good. T plus 2 and t minus 2. Because we know that the square root of 4 is 2. Okay? Now what we're going to do is we're going to set each part equal to 0, including that negative 16. So we have negative 16 equals 0. That's a false statement. Okay, so that doesn't make sense. Then we're going to do t plus 2 equals 0, which gives us t is equal to negative 2. And then we have t minus 2 equals 0, which tells us t is positive 2. Only one of those answers is a true answer. Would it be negative 2 or positive 2?
Positive.
Positive 2. Why positive 2?
No negative time.
Good. You can't have negative seconds. So since you can't have negative seconds, this wouldn't work. So then this tells us that the stone hits the water after how many seconds? 2 seconds. So stone hits the water at 2 seconds. Okay. If you're answering a question in your word problem, you need to make sure your answer is in a sentence. Okay? A sentence that just explains the answer. I'm not looking for any proper grammar or anything. Punctuation. As long as you're answering the problem. Okay. So those 3 examples were applications of quadratic equations. Now in the next example, we're going to look at the Pythagorean theorem. Okay. So this may sound familiar to some. So the Pythagorean theorem is a way to solve the sides of a right triangle. The equation for Pythagorean theorem is this right here, that a squared plus b squared equals c squared, where a and b are representing the lengths of the sides, and c is representing that length of the diagonal, which is called the hypotenuse. So in the first 2 examples, we're just going to be using the Pythagorean theorem to solve the missing side. And then in the rest of the examples, we're going to be using the Pythagorean theorem with the quadratic equation applications. Okay? So number 4 says find the length of the missing side. So the first thing I like to do is write my equation down. So a squared plus b squared equals c squared. And then I'm going to go through my triangle and I'm going to label a, b, and c. So that missing value here is going to be what side? A or b? Good. So a, The 6 is B, so that means the 10 is C. That diagonal is always C. You can mix up the A and B values, and it's not going to change your answer, but that C has to be the diagonal. Okay, so now we plug everything in. We don't know A, so we're going to say A squared plus B we know is 6, so plus 6 squared is equal to C, which is 10, so 10 squared. Okay. Once we have everything plugged in, now we're going to solve. So A squared, it just stays A squared for now. What's 6 squared? 36 is equal to 10 squared, which is 100. What would we do to get A squared by itself? Subtract 36. So we have A squared is equal to 64. And how do we get our A value? Take the square root. So that means we have A is equal to what number? 8. Okay. Since we're dealing with an object, we know our answer has to be positive. So that's why it's just A is equal to 8 feet. Technically, when you take the square root of something that is squared, not only would we get the positive 8, we would get a negative 8, because if we took negative 8 squared, that's still 64, okay? But since we're dealing with an object, we know we can't have negative 8 feet. So that's why we didn't consider this one, okay? So our answer is A equals 8 feet. Okay, number 5, again, wants us to find the missing length. So we have A squared plus B squared equals C squared. Okay, what length are we missing? What do we want to label that missing length, A or B? Good, we can label it A again. That just means this 9 is going to be B and the 15 is going to be C. So if I plug everything in, I get A squared plus, what's B? I'm going to write each step. So 9 squared is equal to 15 squared. So I have A squared plus, what's 9 squared? 81 is equal to, what's 15 squared? 225. I'm going to subtract that 81 over, and I get A squared is equal to what number? 144. So if I take the square root of both sides, I'm going to get what two possibilities? Positive 12 and negative 12. So I'm going to get a positive 12 and a negative 12. But the only possible answer here is going to be what? Positive 12, because we can't have negative 12 meters. So this is my answer, meters. Okay. Any questions on using the Pythagorean theorem? Now let's look at number 6. Number 6 says a 13-foot board is used as a ramp to unload furniture off a loading platform. If the distance between the top of the board and the ground is 7 feet less than the distance between the bottom of the board and the base of the platform, find both distances. Okay, so we have a diagram here. We have a board being used as a ramp. Okay, so that's our diagonal part. We have it being set on a loading platform. Okay, so that's one side. And then this base is the ground, right? So we have a right triangle. Now we're going to have to label the sides. So it says the distance between the top of the board and the ground. So this distance right here is 7 less than the distance between the bottom of the board and the base. Okay. So how would we write 7 less than something? Because that something is our variable.
7 minus 7.
Minus 7. If you see less than or more than, that number comes after. So let's say x minus 7. And it doesn't tell us anything about the bottom except that there's a distance there. So what would that distance be represented as? Just x, right? Because the this distance here said the bottom distance minus 7. So the bottom distance we're labeling as x, so there just has to be an x here, an x here. We're going to have the same variables, just one of them is being manipulated. And then how long did it say this board was? 13. So that 13 goes here. Okay. Now we have what looks like a right triangle. That should tell you in order to be able to solve this, we're using the Pythagorean theorem. So we have a squared plus b squared equals c squared. We can go ahead and label our sides. So we know 13 is going to be c, and then it doesn't matter the other sides. They could be a, b, or vice versa, as long as we have our c on the diagonal. Now that we have everything labeled, we're going to plug things into our equation. So our a squared is going to be represented by what? X squared, good. And then plus b squared, how would I write x minus 7 squared? Am I going to have that in parentheses? Yes. So x minus 7 squared equals c squared, which is just 13 squared. Okay. From here, we need to simplify this in order for it to look like a quadratic equation. Okay. So we know that if we have a parentheses that's being squared, that's the same as writing that parenthesis how many times? 2 times, because it's being squared. So we have x squared plus x minus 7 times x minus 7 is equal to 13 squared, which is 169. So how are we going to simplify these parentheses? Distribute. There's another name for it when we have two binomials. FOIL. So FOIL means we distribute the first term and then the second term. But this is called the FOIL method since we are distributing twice. Okay, so once we do that, we're going to have, I'm bringing down that x squared. So we have x times x, which is x squared. X times negative 7 is negative 7x. Negative 7 times x is again negative 7x. And negative 7 times negative 7 is a positive 49. And I'm bringing down that equals 169. Okay. Now I'm going to combine like terms. What like terms can I combine here? The x squares and what else?
7x.
The 7x. Okay, so I have 2x squared minus 14x plus 49 is equal to 169. I want my quadratic equation to look like standard form. And in standard form, I have it equal to 0. So what do I need to do to that 169?
Add it to the equation.
So not add it, because it's already positive. Subtract it. We're going to move it over to the other side by subtracting that 169. So when we do that, we have 2x squared minus 14x minus 120 equals 0. Okay. So now we have something that looks like the standard form, ax squared plus bx plus c equals 0. Before we start factoring this, we always have to check if we can take out a what? A GCF. And what would be the GCF we could take out of here? 2. So if I take out a 2, I'm left with x squared minus 7x minus 60, and then of course equals 0. Okay. Now that we've taken out that GCF, what is the only part we're trying to factor here? Good, everything in the parentheses. Okay, so using that AC method, A times C, I'm going to have 1 times negative 60, which is negative 60. And what's my B value? Negative 7. So I need two numbers that multiply to negative 60 but add to negative 7. What would be those two numbers?
12 and 5.
Good, 12 and 5. Which one's negative?
12.
12. So negative 12 times 5 gives us a negative 60. But if I add these together, I get a negative 7, meaning I'm using the numbers negative 12 and positive 5. So I have, let's see, x squared minus 12x plus 5x minus 60 equals 0. Okay, so that tells me I'm going to do factor by grouping. And what's the GCF I can take out of the first term? Just an x, so I'm left with x minus 12. And what about the second parenthesis? Good, a 5. So again, I'm left with x minus 12. So now I have the factors x plus 5, x minus 12 equals 0. But what am I forgetting in the front?
The GCF.
The GCF. So I'm going to bring down that 2. Can't forget about the GCF. Now that I have everything there and everything factored, what am I doing to each part? Setting it equal to 0. So 2 equals 0, that's false. That doesn't work. X plus 5 equals 0 gives me x is equal to negative 5. And x minus 12 equals 0 gives me that x is equal to 12. Okay? There's only one possible answer here because we're talking about length. So which one are we crossing out? The negative 5, because we can't have negative length. Okay. So that means we have x equals 12. Is that x equals 12 our only answer here? Let's look back at our diagram. That 12 just tells us this. Okay. What do we need to do to the 12 in order to find our B value? Subtract 7. So 12 minus 7, 5. So we get that the distance in both directions for A and B is going to be 12 feet and 5 feet. Okay, so 12 feet and 5 feet. Okay. We have to make sure that we go back to our original problem in the beginning to make sure we are getting all the information that the question is asking us. Okay. So in these type of problems, I do require to see a lot of work here. There's not any part here that I would expect you to do in your head and just write the answer. Okay. Any questions on 6? Let's look at number 7. Number 7 says a 5-yard ladder leans against a wall. So we know right away this is going to be a similar problem. The distance from the bottom of the wall to the top of the ladder is 1 yard more than the distance from the bottom of the wall to the bottom of the ladder. Find both distances. So again, we know we are going to have a diagram that looks like a right triangle. So I'm going to go ahead and draw that right triangle. It says a 5-yard ladder leans against the wall. So that 5 is going to go where on the triangle? The diagonal. So 5, well, I don't want to write the things just here so you don't confuse them. So 5 yards on the diagonal. And then the other one says the distance from the bottom of the wall to the top of the ladder, so this distance here, is 1 yard more than the distance from the bottom of the wall to the bottom of the ladder. So what is going to be on this part here?
6 yards plus, B or the other side.
So something plus 1, right? So we got to name a variable. If we can choose any variable. Let's not confuse it with the A, B, and C of the formula, though. So we would typically just use X. And it says 1 yard more, so X plus 1. So it's looking similar to our other diagram. So that means the, what is going to represent the bottom part?
X.
Just X. Okay. So now it wants us to find both distances. It wants us to find X and X plus 1, so A and B. So we write our formula, A squared plus B squared equals C squared. We label our triangle, and we plug everything in. So in this case, A is going to be what? X. So we have X squared plus B is going to be X plus 1. Do I put that in parentheses?
Yes.
Yes. X plus 1 squared is equal to C squared, so 5 squared. Okay. What does this X plus 1 squared tell us? How are we going to rewrite that? 2 times. We're going to write X plus 1 2 times. So I have X squared plus X plus 1. X plus 1 equals 5 squared, which is 25. How am I going to simplify those binomials? FOIL method, okay. Okay, so bringing down my X squared. Now doing the FOIL method, X times X is X squared. X times 1 is 1X, or you can just write X. 1 times X is X, and then 1 times 1, 1, bring down, that equals 25. Now I need to combine like terms. What are my like terms in this case? Good, the X squareds and the X's. So I have 2X squared plus 2X plus 1 equals 25. What's my next step? Good, subtract 25 over, because I want it equal to 0. So 2X squared plus 2X minus 24 equals 0. Okay. Is this now in standard form? Yes or no? Yes, it's in standard form. So that means before we start factoring, we have to always check if there's a what? GCF. And what would be the GCF for this problem? 2 or 2X? 2, because remember it can't be X because that negative 24 doesn't have an X. So just 2. So GCF equals 2. So if we take out a 2, we're left with X squared plus X minus 12 equals 0. Okay. Now we're doing the AC method just on that middle part, what's in the parentheses. So if I do A times C, what is A times C?
1 times -12.
Good, 1 times negative 12, which is negative 12. And what's our B? 1, because we don't see a number in front of X, so that B value is 1. So I need 2 numbers that multiply to negative 12, but add to 1. What would be those numbers?
Positive 4 and negative 3.
Good, positive 4, negative 3. Because if I multiply them, I get negative 12. And if I add them, I get positive 1. So then I have X squared plus 4X minus 3X minus 12 equals 0. I just plugged in those factors that I found. Now doing factor by grouping, what would be my GCF I can take out of the first parenthesis? An x. So I'd be left with x plus 4. What about the next parenthesis? Good, -3, because I want my parentheses to match, right? If I just took out a +3, I would be left with -x minus 4, which doesn't match. So I have x minus 3, x plus 4 equals 0. What am I missing in the front? My GCF, so 2. And now what am I doing to every term? Setting it equal to 0. So 2 equals 0 is a false statement. X minus 3 equals 0 tells me that x is going to be what? +3. And then x plus 4 equals 0 tells me that x is going to be -4. We're talking about distances. We're talking about yards. So which one does not make sense? -4. We can't have a negative distance. So that means the only thing that makes sense here is that x equals 3. But is that our only answer? Looking back up at the original problem, right here we have x is equal to 3 yards. Okay, how do we find our b part? Good, so 3 plus 1, which gives us 4 yards. So that means the two distances were what? 3 yards and 4 yards. Okay, so 3 and 4 yards. Okay. Any questions on 6 or 7? Remember, these are being recorded if you want to go back and watch them later.